We're going to be talking about something called conic sections, but before we begin talking about those with the next lesson, in this lesson we're going to look at some relationships between points, specifically their distance and midpoint. This is the distance formula to find the distance or the length between 2 points. It will not be provided for you on the test, but there is a way to get around it without having to memorize the formula. Basically, what this formula is doing is a Pythagorean theorem. So for our examples, I'll show how to do it using the formula. If you're a formula person and you're like, yeah, I can memorize that, no problem, that's fine. Or if you're like, yeah, I'm not a formula person and I can't memorize things, there's a way to get around it without having to memorize the formula. So if you are a formula person, that formula said we have the square root of our x's subtracted squared and our y's subtracted squared. So it doesn't matter which one is your x2 and which one's the x1, but we just need to subtract x's. So we can do 3 minus negative 2, and we're going to square that, and subtract our y's likewise. So negative 1 minus 5, and we're going to square that. So that would give 5 squared plus a negative 6 squared. It's important that you are careful with your negatives here, because when I square a negative 6, what do I get? A positive 36. Squaring makes everything positive. So add that together and I get the square root of 61. I do not want decimals for answers. So if the square root is not a perfect square root, leave it as a square root, but check to see if it can be simplified. So when we talked about simplifying square roots, we talked about how we want to look for a perfect square that divides into there. There are no perfect squares that divide into 61, so that's just going to be our final answer. But if it can be simplified down, it should be, but no decimals. We want exact answers. So that's the formula method. If you're feeling like memorizing that formula for the test is not going to be a good thing for you, the other way to do this is to plot our 2 points. So negative 2, 1, 2, 3, 4, 5 for the first point, and 3, negative 1 for the second point. And what we're looking for here is the distance between those 2 points, so the length of the segment that would connect those 2 points. So what I'm going to do is make a triangle out of the points. Then we can count out the lengths of the sides. So counting out for the vertical, we can count out how many tick marks we've gone. 1, 2, 3, 4, 5, 6 is the height vertically. And we can count out the horizontal length. 1, 2, 3, 4, 5 units horizontally. And then we can just do a Pythagorean theorem on it. So 6 squared plus 5 squared equals c squared, which would give 36 and 25. And to get the c alone, we take a square root. So we end up at exactly the same answer as before. I'm a pretty visual person, so I tend to stick with drawing it out instead of trying to memorize formulas. When I memorize things, I tend to memorize them backwards, or I just kind of mess up details of formulas. So I'm a pretty visual person, but if you're a formula person, feel free to use the formula. Just know that I will not be giving it to you on the test. Yes, this is done in geometry classes sometimes as well, so you may have seen this formula before. Go ahead and try the next one. Okay, so you could apply the formula on this if you would like to do that, or you can plot it out to negative 4 and 5, negative 1, and connect. Count out the height, which would be 3, and the length, which would be 7. And Pythagorean theorem would then give us the square root of 3 squared plus 7 squared, which is the square root of 58. Which would be the same exact thing you get if you chose to use the formula.
Do you want us, like, if we're taking the test, do you want us to do that
You do not have to draw it out. If you're a formula person and you can just plug it into the formula, that's fine to just do that. Otherwise, if you're a picture person, then you need to draw out your picture so you can see what's going on. From 58, we want to think about, does anything divide into there that's a perfect square? 2 definitely goes in, but 2 goes in 29 times. 29 being prime means that that thing's not going to break down at all. But that is something we should consider. If that square root can be broken down, it should be broken down. Questions on distance? Our next question asks us to classify the triangle created by these 3 points as being scalene, isosceles, or equilateral. So we need to remember what these terms mean to be able to classify it. So what does scalene mean? No sides are equal. Isosceles? 2 of the sides are equal. And equilateral? All of the sides are equal. So what we need to do is find the length of AB, the length of BC, and the length of AC, and say how many of those are the same. You can definitely use your distance formula here, but for these ones, I'm really a picture person, and I'll show you why. So, if I plot out the 3 points, point A is at 4, 6. Point B at 6, 1. And point C at 1, 3. And connect to get my triangle. Do not just look at the triangle and say, oh, it looks like it. That's a really dangerous thing to do. Okay, looks like it is a risky thing. So what I want to do is see how long are these sides. Now, like I said, I'm a picture person when it comes to these triangle questions. And what I do is I create my triangles by going out of the original one. So by connecting A and B, I'm going to head in the direction that I'm not going to overlap the triangle that's already there. It has sides of 2 and 5 then. So for AB, I would get the square root of 2 squared plus 5 squared, or the square root of 29. When I connect B and C, again, I'm going to connect out of the triangle so I don't overlap at all. And that gives me sides of 2 and 5. That's exactly the same as the other one, so I don't even really need to recalculate this. BC also has to be the square root of 29 because those 2 triangles are exactly the same. They're just pointed in a different direction. And then when I connect A to C, this whole thing should make a square. Got sides of 3 and 3 there. And so that would give me the square root of 3 squared and 3 squared, which is the square root of 18, which could be broken down. We don't have to on this problem because this problem didn't say find the lengths. So these aren't our final answers, so you don't need to bother breaking it down. But as a point of review, if this was our final answer, what goes into 18? 9, which has a square root of 3, so that should be 3 square roots of 2, would be the answer I was going for there. So you need to simplify square roots the way that we've learned earlier this year when possible. But this question asked what kind of a triangle is it? So we had 2 square roots of 29, a square root of 18, so that means that this triangle is isosceles. Questions? Yes. You could use the same formula. You would just have to apply the formula to point A and B, and then to points B and C, and then to points A and C. So you can use that same distance formula. You're just going to have to apply it to each pair of points. It's a totally valid way of doing it. I think the picture's a little bit faster, but that's just me. So if you want to use the formula, you can definitely use the formula. Go ahead and try the next one, which is already drawn out for you. All right, so if I start connecting, if I connect E to F, I have a side of length 1 and 2. So EF would end up then being the square root of 5. Connecting D and F, I get a 1 and a 3. So DF is going to be the square root of 10, applying the Pythagorean theorem to those numbers. And for the last two, I get sides of 2 and 3. So that means that ED would have a length of square root of 13. Those are all different. So that means that this triangle is what? Scalene.
Sister,
Yes.
do we have to do like little stuff on the side? Can we just...
I wouldn't just look at the starting triangle and say, oh, it looks scalene. But once you draw in the other 3 triangles and see that all the numbers are different, then you could go for that. Right, so you don't have to give what those links are. Nope, the final answer is just going to be one of the 3 words. So you got kind of like a 33% chance to guess it right if you just want to do that. All right? The midpoint formula also will not be provided on the test. I don't have a pictorial way of thinking about this. But what the midpoint formula is doing is taking the average of the x's and the average of the y's. Because if we're looking for the middle of something, we're looking for the average. So we add together the x values and divide by 2, and add together the y values and divide by 2. So to find our midpoint here, I'm going to add the x's and divide by 2, and add the y's and divide by 2. So that gives me negative 9 over 2 and 6 over 2, which is 3. So just add up the x values, divide by 2, add up the y values, divide by 2. And that point should be exactly in the middle of the other 2 points. Questions? Decimal is fine, or fraction. So negative 4.5 would be fine as well. So for this one, add the x's, divide by 2, add the y's, divide by 2. So that gives me 8 over 2, which is 4, and negative 11 over 2. Or negative 5.5 is fine for that as well. That's the answer. Yep. Questions on midpoint? For our last type of problem, I'm going to tell you it's going to be a process. Okay, so these problems are definitely not as quick as the last ones. We are asked to, in this problem, write an equation. So an equation, we're thinking of like a y equals mx plus b. Okay, a linear equation for the perpendicular bisector of the line segment that joins 2 points. I'm going to draw you a picture to show you what we're finding, but in solving, a picture is actually not going to be helpful to us in these problems. But just so that you can see what it is we're actually going for here. If I plot the 2 points, so I have a point A is at negative 1, 4. And B is at 5, 2. Oops, 2. And connect those. This problem says that we're looking for the line that would be the perpendicular bisector. What does perpendicular mean? Hits at 90 degrees. What does bisector mean? Hits in the middle. So we're looking for the line that hits right in the middle and would hit at 90 degrees. And what we want is the equation of that line. So like a y equals mx plus b equation of that line. So the picture's not going to help us find it, but just so that you visually know what it is that we're doing here. It's saying if we would connect those 2 points, we're looking for the line that would go right through the middle, hitting at 90 degrees. So the process of finding this is going to be a 4-step problem. First thing we're going to do is find the midpoint. because we have to go through the midpoint for it to be a bisector. So to find the midpoint, we add the x's, so 5 plus negative 1 and divide by 2, and add the y's, 2 plus 4 and divide by 2. So that gives me a midpoint of 2, 3. So now I know my line's going to go through that point. Second thing we need, when writing an equation of a line like y equals mx plus b, m is a pretty important thing. What does m stand for? Slope. So our second thing is to find the slope between the 2 points. We learned about this a long time ago. That's why I kind of like these problems, because there's a lot of review in this problem. What was the formula, or how did we find slope between 2 points? Rise over run visually. So if we plot it out, we could do a rise over run, but just from the numbers. Change in y over change in x, or y2 minus y1 over x2 minus x1. A change in a y over a change in an x. So we're going to subtract the y values. This will be 2 minus 4 over, subtract the x values, 5 minus negative 1. Which gives me negative 2 over 6, or negative 1/3. Okay, so first step is to find the midpoint using the midpoint formula from our notes today. Second step is to find the slope, and for that we have to think all the way back to chapter 2, where we learned that a slope is the change in the y's over the change in the x's, or subtract the y's, divide by subtract the x's. Next, the line that we're looking for is supposed to be perpendicular to the segment that was between these 2 points. So back in that chapter 2, when we talked about slope, we also talked about what it means to be perpendicular in terms of slope. And what was that?
Would that be the opposite reciprocal?
The opposite reciprocal. So if the slope we found in step 2 is negative 1/3, the slope that we will need to use is positive 3. Reciprocal, flip it upside down, so 3 over 1. And opposite, so one of them should be positive and one of them should be negative. And our final step is to apply y equals mx plus b using that perpendicular slope and using our midpoint as our x and y. So y in the midpoint is 3, perpendicular slope was 3, x was 2, and we don't know the b value, but we can solve for it. Yes. Yep, perpendicular slope is opposite sign and flipped over. So I can subtract 6 and find my b value. And our final answer is using the b value and that perpendicular slope to write our equation, y equals mx plus b. So that picture that we drew at the beginning, this would be the equation that graphed out that line of the answer.
Oh, so we have to solve for the what we have m for that formula, use the x and the y.
Right, so we use the x and the y of our midpoint. We use our perpendicular slope as the m, and we solve for the b value. Okay, so these problems are a process. We'll do the next one together as well. So once again, just kind of take good notes through it. You're going to have 4 of these on your assignment. So don't be like, oh, I'll just forget about that type of problem. 4 problems is kind of a big deal. So just take good notes through, and we'll do the next one together as well. So step 1 was to find the midpoint. So in question number 8, we add the x's, which is 1 plus negative 2, divided by 2. You don't need to graph it. Nope. and add the y's, which is 4 plus 1, divide by 2. So our midpoint is negative 1/2, 5/2. Decimals are fine as well, as long as they're nice and clean decimals like these would be. Step number 2 is slope. And for slope, we do change in y, so subtract the y's, 4 minus 1, over, subtract the x's, 1 minus negative 2. Careful of double negatives, gives us 3 over 3 is 1. So that's the slope of the segment that connects our points, but our line is supposed to be perpendicular to that. So step 3 is to find perpendicular slope, which is what we're going to call our m, which would be what? Negative 1. The reciprocal of 1 is still 1. 1 over 1, flip it over, still 1 over 1. But then it also has to be opposite. 1 has to be positive and 1 has to be negative. And step 4 is to apply y equals mx plus b to that perpendicular slope and to our midpoint as being our x and y. So 5/2 equals negative 1 times negative 1/2 plus b. So 5/2 equals positive 1/2 plus b. Subtracting 1/2 from both sides gives us 4/2 or 2 is b. So our final answer is the y equals mx plus b with a perpendicular slope and b plugged in. So y equals negative 1x plus 2, or just negative x plus 2. Okay. Questions?
I have a question. How do you get that last, like, y equals?
What's in the black box?
Yeah.
I do the y equals mx plus b again, but letting y and x be our variables as they should be in an equation, and plugging in the m from step 3, so negative 1, and plugging in the b that we found in step 4.
Okay.
All right. Your homework is from 10.1, and that will be due Monday.